In this class, we will learn about simplex method. So what is simplex method? Why should we read simplex method? Up to now, we solved the equation, two-dimensional equation, using graphical solution. But what if the number of equation is more than 2, number of variables are more than 2? So in that case, we need some extended or generalized version. Now here, to solve using simplex method, we need some terminology, protocols or procedures. We have to convert any type of LPP to standard form. Why it is needed? So that will be discussed also. So in standard form, generally the objective function is taken as maximized type, and the equations will be less than equal to type, but we have to convert these inequations in equal form, that is equality form. For example, you can see that the first constraint is 7x1 minus 3x2 less than equal to 15, and which is an equation, but it will be converted to an equation 7x1 minus 3x2 plus x3 equal to 15, as you see that left hand side is less than equal to right hand side, so you have to add something, some value, and that value is x3, and it is called slack variable here. So x3 is slack variable. Similarly, the right hand side of the second constant is greater compared to the left, and that is why you have to subtract something positive value, and which is x4 here, so that is called surplus variable. So 3x1 plus 4x2 minus x4 equal to 20. So this is the converted equation. And for the last case, you can see, so 5x1 minus 4x2 equal to minus 60. It is an equality, but there is a negative sign in the right hand side. So as per the standard form, this should be positive value, so multiply with the negative. Now this is the converted, where all the xi's are positive. Now take any two equations. So the equations are x1 minus 2x2 plus x3 minus x4 plus 2x5 equal to 2, and another equation x1 minus 2x2 minus x3 minus 3x4 minus x5 equal to 4. If you are given these two equations, and you are asked to solve these two equations, so what you do generally, add some scalar, I'll multiply some scalar and adding or subtracting. These are two operations you generally do. So in that case also we are doing the same. So R2 minus R1, so R2, that means row 2, here you can assume it as equation 2 minus equation 1, and it will be put in equation 2. So first equation is unaltered, and for the second it is reduced by the operation, and it is x2 minus 2x2 plus x4 minus 3x5 equal to 2. Still we need another operation for the target case, and another operation is r1 plus 2 r2, and it is x1 minus 3x3 minus 2x4 minus 4x5 equal to 6. Now if you check that further solution is not possible, because the number of equation here 5 and number of variables are 5, and number of equation is 2. Okay, so this kind of solution, this kind of system of linear equation has infinite solution. So one solution is putting x3, x4, x5 is 0. We have x1 equal to 6 and x2 equal to 2. And this kind of solution are called basic feasible solution. You know about the basic solutions. So where you have to put the n minus m variables is equal to 0. So n minus n variables here, number of variables minus number of equation equal to 0, and the remaining variables may be 0 or may not. So this kind of solution is a basic solution. Here x1 equal to 6 and x2 equal to 2 is a basic, with the x3 and x4, x5 equal to 0 is a basic feasible solution. Feasibility because of its positive values of x1 and x2. Now these variable xi, that is x1, x2 here. So a variable xi is said to be a basic variable if it appears with a unit coefficient in an equation I and 0 in all other equations. So what I have said earlier, and those variables which are not basic are called non-basic. These are already discussed in our previous class. Now okay, by applying an elementary row operation, any given variable can be made to be a basic variable, and this is called a pivot operation. It will be cleared in the next set of examples. And you know about basic feasible solution, so I am skipping this now. So this is our main theme in this class, and it is the simplex method. What I have discussed earlier, now it will be helpful for understanding simplex method. Okay, so we have an objective function maximize z equal to 5x1 plus 2x2 plus 3x3 minus x4 plus x5. So it has 5 variables and 2 equations. So x1 plus 2x2 plus 2x3 plus x4 equal to 8, and 3x1 plus 4x2 plus x3 and plus x5 equal to 7, where xi greater than equal to 0. So non-negativity condition is there. Now we have to prepare the initial table. Okay, so the initial table here, in the first row, the coefficients of the variables in the objective function are put. So 5, 2, 3, minus 1 and 1. So look at the objective function here, 5, 2, 3, minus 1 and 1. Okay, now in the second row, C0, basis and the variables, and right hand side. So right hand side you can see 8 and 7. So 8 and 7 is there, and the variables x1 with the coefficients 1 and 3 as a system. If you think the system as a matrix, so what will be the first column? That is 1 and 3, which is the coefficient of x1. So that is put under x1. Similarly for the x2, for x3 and x4, x5, like this. Now as we have discussed earlier, the condition of basic variable. So basic variable, in that case the coefficient will be 1 and the remaining values will be 0 in that column. So x4 is matching with that criteria, and x5 is also matching with the criteria. So in the initial basic feasible solution is taken as x4 and x5. Put the basis variable as x4 and x5, and under the column C0 put the corresponding values in the objective function, corresponding coefficients of the objective function, and which are -1 and 1. Now okay, you can calculate here. If you take x4 and x5 as basic variable and the remaining are 0, then the values of x4 equal to 8 and the values of x5 equal to 7, and in that case the objective function will be -1 into 8. So that is z equal to cx form, so -1 into 8 and 1 into 7. If you add them, so it will be -1. And what is the deviation? So deviation is 5 minus 5 means you can check here the first column, 5 minus -1 into 1 and -1 into 3, and that is 6 minus 3 is 3. And for the second case, 2 minus of -1 into 2, that is 4, and minus of 4, that is equal to 0. And similarly the other calculation is shown here, and you will find the deviations. Now we have calculated the table, and we have found that z equal to -1, and it is a basic feasible solution with the objective function value as -1. So it may be a maximum value, but we have some criteria that deviation should be 0 or negative. But here we have the positive value, so 3 and 4, and our target will be to get entry which has the maximum value, and it is x3 here. So x3, the variable x3 will enter to maximize the objective function z, and we have to find we have to fix the variable which will be leaving. In that case we have to calculate the minimum ratio, and minimum ratio is the right hand side divided by the elements under the x3, which is the entry variable. So 8 by 2, which is equal to 4, and 7 by 1. Now out of 8 by 2 and 7 by 1, the minimum one is 4, that is 8 by 2, and so leaving variable will be x4. Now x5 will be there, and the entry variable will be x3. So the new basis will be x3 and x5 with the c0 will be as 3 and 1 as discussed earlier. Okay. Now we are moved to the second table, and the same calculation will be there. So only thing you have to remind that the basic variables are x3 and x5. So x5 is as it is, but you have x3 as basic variable, so put the column as 1 and 0. Put the column of x3 as 1 and 0. Now look at the first table here. So if you put the variable, if you want to make the value of 2 as 1, so you have to divide simply by 2, and in that case it will be half, 1, 1, 1 by 2, 0 and 4 for the row. Okay, and you have to get the value 1 and 0 under x3. So in that case, r3, okay, so r3 minus r1 by 2. So r3 minus r1 by 2, that means 3 minus half, that will be 5 by 2. So if you take that calculation, and it is 5 by 2 and 3, 0 minus half, 1 and 3. 3 means there was 7, so 7 minus 8 by 8 by 2, and it is 3. Okay, so similar calculation. So here the objective functional value is 3 into 4 and 1 into 3. So 12 plus 3 equal to 15. Because all other variables, that is x1, x2 and x1, x2 and x4 are taken as 0, and only x3 equal to 4 and x5 equal to 3. So you have the objective function as 15. Now it is another VFS. So we had one VFS, that is initial VFS, and we have now another alternative VFS which has better value, greater value, you can say, of z. So is it maximum value? So in that case, again we have to check the deviation, and deviation is similar, 5 minus 3 into half minus 1 into half. So what it is, and 3 by 2, and it is so almost 4, and 5 minus 4 equal to 1. So deviation is 1 here, and the remainings are 0 as calculated in the table. Now as it is positive value, so it should be continued, and for x1, the x1 is the entry variable, and you have to find the minimum ratio, and minimum ratio is 4 by half, it is 8, and 3 by 5 by 2 equal to 6 by 5, and which is minimum. So x5 will leave and x1 will enter. So that in that case, the new basic variables are x3 and x1. So x1 in place of x5, with the x1 has the coefficient in the objective function as 5. Now we have the third table, and you can say after putting the same procedure, after putting the values of x1 as 0 and 1, as you have x3 in the first row, so it will get 1 0 for the column under x3, and similarly for the column under x1 will get 0 1 as the property of basic variables. And you can see here the deviations are 0 or negative. So deviations are 0 or negative, so it must be stopped here, and we have to calculate the maximum value, which is x3 equal to 17 by 5 and x1 equal to 6 by 5, and put all other as 0. So in that case, the z equal to cx will be 3 into 17 by 5 plus 5 into 6 by 5, and which is equal to 18 by 5. So this is the final table, and you have the much better values of z, and it is the third BFS. So this BFS, in this BFS we get the maximum value actually. So the previous one, it was 15, and it is more than 15. Okay, so this is the maximum value, and the solution are taken as x1 as 6 by 5, x3 as 17 by 5, and x1, x4, x5 are 0. So minimum objective function, maximum objective function value is 81 by 5. Okay, now it is your turn to solve the problem given in the slide. Check it. It is minimization problem. So think about it. We will discuss for this case, for that type of problem in the later, but you can still solve it. And x3 is unrestricted in sign, so this is new for you. So x3 is unrestricted in sign means it may be positive or negative, so you can write x3 as the difference of two positive value. You may say x3 prime and x3 double prime. So if x3 prime is greater than x3 double prime, then it will be positive, otherwise negative. So x3 will be taken as a difference of another two variable, x3 prime and x3 double prime. And remaining things are same, so you have to put in the standard form and then solve it. Another problem, maximization problem. So it is much simpler than previous one. Okay, thank you very much.